Thank you so much. See, last class we have discussed so many things, and lastly we are discussing about the misconceptions in data science, right? And the misconception was that is said correlation is causation, but we said that correlation does not always cause the effect of another one. That means we cannot say that correlation always implies causation, right? So we had also studied what is the meaning of correlation. Okay, so correlation means what? It was the relationship, the association between two variables, right? And as I informed you, what was the meaning of variable? Suppose we want to perform an analysis, we want to do something, then we need some output, right? So depending upon the input, we have to gather the output. That means whatever will be our output, that depends upon the inputs we have given. So we are manipulating something, then we are getting something after analysis process. So whatever the things we take as input and whatever the things we receive as output, all the things are called as variables, right? So in order to find the association of the variables for the analysis purpose, we need the method of correlation. So correlation says what is the association between the variables or how the variables are related with each other. So this is the brief recap of what we taught yesterday, right? So that everyone will have a fresh knowledge or the fresh recall of the things that already passed. Okay, so this was correlation. So if we say the types of correlation, there are three types of correlation, that is positive correlation, negative correlation, and zero correlation, which we otherwise call as no correlation, right? So what about the positive correlation? Positive correlation means two variables are related in a particular direction or in a same direction. That means if we can say, if we increase the input, the output will be increased. If we decrease the input, the output will be decreased. That means both the variables, both the input and the output variables, or those things that are related for the analysis purpose, those variables move in the same direction. For example, experience and salary. So if an employee has more experience, he or she can expect much more salary. So both experience and salary are related with each other in a same direction. So that is called positive correlation, right? Second one is called negative correlation. That means both the variables are related in not in a same direction. That means if you can say, if the input increases, output decreases, or if the input decreases, output increases. That means whenever we talk about two variables, these variables are inversely proportional. That means if one increases, another decreases, and vice versa, right? For example, if we just climb the top of the hill or the mountain, we can experience there is less oxygen. That means the higher we'll go, we will have less oxygen. So here the two variables, the height increase and the oxygen level decrease, these two variables are negatively correlated, right? Another one was zero correlation or no correlation. That means there was no relationship between the variables. We can say that if we take T, it won't affect the intelligence level. Here two variables, intake and output. That means input of T and what we expect, the level of intelligence should be increased, that are not correlated with each other. There is no relationship between the intake of T amount and the level of intelligence, right? So that is called zero correlation or no correlation, right? So this we have studied, and this was the diagram. This is of x-axis and y-axis. So if x-axis, the variable that is plotted in the x-axis increases, the variable plotted in the y-axis also increases. So that was positive correlation. Negative correlation means suppose the variables are plotted in the x-axis and the variables here are plotted in the y-axis, right? So when the variable, the x increases, we can say the variable, the values plotted in y-axis decreases or vice versa, right? So in this case, here this was zero correlation. That means these are the values. The values are not related with each other. So this is called zero correlation. So these things we have already studied. So these are the brief recap of the things. And one thing you know that when I'm saying the variables are of two types, that is independent variable and dependent variable, right? So always remember that whenever you are talking about the variables that is used for data analysis purpose, there are two types of variables, dependent variable and independent variable. So what are these two? Suppose you are manipulating something, you can manipulate something, that type of variable or that type of intake or that type of thing is called independent variable. Whenever we expect something, we are in the need of something, that is called dependent variable, right? Suppose for example, let's explain that with an example. Suppose I say, if I will take the I will take Horlicks as input, growth level of a child can increase, right? So my analysis will be, if I will provide the Horlicks or the glasses of Horlicks or the cups of Horlicks to a child, the height of that child will increase. So I want to analyze these things, that whether after taking the Horlicks intake, the height of the child will increase or not, I have to check. So my input is the quantity or the intake of Horlicks. My output is I want to check the height. That means I want to check the height. That is my output. So which one or which thing I can manipulate? Tell me, which can I manipulate? Whether the intake of Horlicks or the height of the child? This is a question to everyone. Just say me, if I want to do the analysis that whether after taking the Horlicks as input, the height of a child will increase or not. This is my aim. This I want to analyze. So my question for you all, tell me which one I can manipulate. Are you getting my points, everyone?
No,
I
come
have discussed
again.
about two things. Yeah, just write your answers in the chat box so that everyone will be clear. If anyone knows the answer of my question, please write in the chat box that if we will consider the input of Horlicks and we want to know the growth of height of a child, among these two, which one we can manipulate? Manipulate means we can change, we can increase or decrease in the amount. Which one we can do? Please write your answers in the chat box. It is very interesting, right? So if you will understand, it will be very easy. Everyone try to write which one we can. Yes, Horlicks. Yeah, Horlicks is a protein drink. Yes. Okay. See, we can manipulate the intake of the Horlicks. That means, suppose in a day, I will provide or I will give the child a cup of Horlicks. Okay. Suppose in the next day, I increase the amount to 2 cups of Horlicks. Next, again, late in the third day, I increase the amount to 3 cups of Horlicks. So day by day, I can increase the amount, the quantity of the Horlicks intake, or I can decrease the quantity of the Horlicks intake. So that is in my hand, that how much I have to provide to the child, and that will, according to the intake, the growth of the child will be affected, right? So here two things are there. I have to manipulate the Horlicks intake, then I will find out what is the impact of that one on the growth of a child. Okay, presentation is not visible. Okay, uh, let me check. Is it visible to everyone? Yes, yes. At that time, I was just switched on my camera, so that's why this was not visible. Right? No issue at all. Okay. So in this case, you can see that I am just discussing the very important topic in data analysis. What are the variables that is mainly required for data analysis purpose? Okay. So generally, if anybody asks you what are the variables, because if you search in the books or you will search in the internet, it is written the variables are. So what is the meaning of variable? Variable is anything that is manipulated or that you need actually after the manipulation purpose. So depending upon these two, there are two types of variable: input independent variable and the dependent variable, right? So independent variable is the variable that we can manipulate, and dependent variable is what that we actually need. So if I will take the example of Horlicks input and the effect of the Horlicks input upon the growth of a child, so we can manipulate the intake of Horlicks amount day by day. We can change, we can increase or decrease the intake of Horlicks, and we have to check what is the impact of that one on the growth of a child. Okay, so here the output is the growth of a child, that is called dependent variable, the actual output that we need from the analysis purpose. And that output depends upon what, which we can manipulate, the input one, right? What is the input one? The intake of the Horlicks amount. So this is called independent variable. So whenever we do analysis, we need independent variable, and depending upon that, we get the output which we call at the dependent variable, right? Am I clear to everyone? The dependent and independent variable. Any query about that? Okay. Thank you. Thank you so much. So the misconception, let me check here. The misconception in case of data science was that always we cannot say if there is a correlation among the variables, that always implies the causation, right? So what is correlation we just discussed right now, and causation means one causes another. That means if x and y two variables are there and they are related with each other, that may be positively related or negatively related, but we always cannot say that y is the output or effect of x, or x is the effect of y. For this example, we discussed yesterday that relate. This is the sales volume of ice cream and the heat rashes, right, during summer season. So these are two variables. These are related somehow. These variables are related because in summer season we just increase the sales volume of the ice creams and we can have the heat rashes. These two are related, correlated with each other, but we cannot say that always the sales volume of ice cream will cause the heat rashes. So there may be any other reason. That means as we discussed, this is why, because this is the reason for the hot summer weather, which forces a people or forces someone to purchase ice cream volume during summer, and this may cause the heat rashes. Okay, so for this, what is the cause? The heat summer, hot summer season is the cause which provides us or which forces us to buy the ice cream, and it may happen that we can feel the heat rashes, but we cannot say these two variables are the cause of one another. We cannot say that this x let the ice cream sales volume is the x variable and heat rash is the y variable. We cannot say that x always causes y. Okay, so though these two variables are interrelated, correlated with each other, but we cannot say always y is the impact of x, right? So this is the misconception that we have in data science. So are you all clear? Up to here we have discussed, right? Okay. Okay. Next, see the various applications of data science. So, is the screen visible to everyone? Yes. Okay. You might be known that data science is applicable in every field, right? So there are so many applications of data science, but here I have listed a few for the example purpose. See that data science can be applied in web searching, right? That means we can find the contents on web due to data science. We can search good websites. We can index the websites too using the data science. Okay, so it data science can also be applied to healthcare system. That means we can detect the various diseases, some curable, non-curable diseases. We can detect the possibility of diseases also. We can establish the relationship of diseases to certain factors. That means we can say what are the factors that causes this particular disease. So we can analyze all these things using data science, and it can also be applicable to transport system. That means we can find the best route using data science application. We can find the logistic support for the customers using this one also. Or we can say that how can we design the automated system? We can design the automated system for data analysis purpose using the application of data science also. So there are broad categories where data science can be applied. Okay. um, okay, the question I have discussed yesterday, everything is fine. Next. Okay. Next, see. Uh, till yet, any doubt, students who want to ask me anything? Clear about the correlation and causation, etc. See, generally question is asked upon correlation also. That what is the meaning of correlation? What are the types of correlation? Even on the regression and classification. Okay, tell me one thing that you have studied machine learning and AI also. It was one of your course in MCA, right? So, can you say what is the difference between classification and regression? Because it is also in our syllabus in data science and big data also. So you might be known in your AI and ML course that you have studied earlier to this one. This my classes, my schedule started. So can anybody just brief me the basic difference between classification and regression? The basic difference between classification and regression. I am asking this one because this is already in our syllabus and you have also studied in AI and ML classes. Okay. Yes. 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 Very good. Yes. Yes. Very good. Yes. Yeah. Very true. Okay, classification means we have huge data set. We have to categorize these data sets into proper classes or labels, right? So in case of regression, we have huge data set. We have to find the value among the data set. After comparing, we are getting a value that is called regression. Okay, so that means if the students, suppose today is the sunny day, and the students few candidates are there, and they asked me that we want to play. Okay, we want to play, they need to play, they want to play. So if I am a coach, so I will just analyze the weather, I will analyze the pitch, then I can say yes, you go to play, or you shouldn't go to play, or you won't go to play right now. Okay, so here yes or no, yes and no, two categories that I divided my answers, that yes you can play or no you cannot play. So this is what these two are the levels or the classes that can be derived from the analysis of the data, which we call as the classification, right? So what about regression? That suppose you are an employee and you went to a bank and you need a loan. Okay, so when you ask the manager that I need certain amount of loan, then the manager will ask certain questions to you or verify the documents. That means the person will ask you the job type you are there, or what is your family background, what is your financial status. Everything will be analyzed by the bank manager. Then the bank manager will say you or inform you what is the exact amount, or what are the amount that you can have as your loan. So whatever the amount you are getting, that is the value after analysis of the data, which we call as a regression, right? So both regression and classification are needed for the prediction purpose. And which one, the classification gives or classifies the value into classes or labels, and otherwise on other side the regression gives you the amount, the value after classifying the data you have. So this is the basic difference between classification and regression. So very good everyone, you know it very well. Okay, next C. Let's share the screen again. Okay, C. C. Then the next part is called data preparation, right? This is data preparation. So, in case of data preparation, you know that if we consider the raw data, that means the data with error or the data with inconsistency, we cannot have the proper output, because whatever the output we need after analysis, or whatever the outputs we expect after analysis, that heavily depends upon the quality of the input. So if we have quality input, then we can have the proper output. So whenever we do analysis, we always ensure that the data that is upon which the analysis is performed, it should be error free, should be consistent one. Okay, so for that, in order to have the assurance that we are working or we are analyzing the proper data, we have to prepare the data, right? So data preparation is a process. You can see here. Let's take the marker. So data preparation was what? It is the process of making the raw data ready for processing. That means whenever we collect the data, you know that we always collect the raw data. Because why we collect the raw data? Because data is collected from various sources. It can have missing data, it can have duplicate data, which is not feasible for our study. So what we do, we just after collecting the raw data, we process it to find, to have it the quality of the data, or we extract the quality of data, and this quality based data is used for the data analysis purpose. So the data preparation is what? It is the process by which we convert the raw data into the data that is in the form of being processed, right? So we can do that. After collecting, we have to clean the data, we have to visualize the data. After exporting, after transforming the data into a particular format, we can visualize the data so that we assure that now this data or this kind of data set is ready to be for further processing purpose. Okay, so this data preparation is otherwise called as pre-processing of data. We have heard that data pre-processing. So data pre-processing is nothing but we have to convert the raw data, we have to transform the raw data into a form so that we can perform analysis upon that. Okay, so that process is called data preparation, right? Then what is the need of data preparation here? First of all, if we prepare the data, if we pre-process the data, it will increase the data quality. How it can be done? So whenever we process the data or whenever we just prepare the data, we clean the data. Okay, so data cleaning means we have to remove the noisy data. Whatever the data we need, that should be appropriate one, that should be according to our need, or which can be applied to the algorithm so that we can have the proper output. So that is called the cleaned data. So as we prepare the data, we have to clean the data, we have to reduce the dimensionality, we have to transform the data into a form so that we can apply any kind of algorithms to upon that data to get the output. So data preparation improves the data quality. Then second one is, what is the another need of data preparation? That it enhances the model performance, right? See, in case of model generation, we need one type of data, that is called the training data. Okay, so whenever let we have so many kinds of data collected and we have cleaned the data or we have pre-processed the data. So if we will generate a mathematical model, if we just generate some guidelines upon the data, that if this will be the data, this will be the inference, if this will be the data, this will be the inference. Suppose basing upon that we have generated a model, right? And whenever we get some testing data, some new data we have, and we want to test that whether this data falls into the category or not, or this data is mapped into the category or not from the model. So if we have generated the model using the cleaned data, after data pre-processing we have considered the data and we have generated the model upon the cleaned data, then we can say that the model that we have prepared is the accurate one and it can map any kind of data in a proper way. So it enhances the model performance if we consider the quality data or if we have prepared the data or pre-processed the data, right? Next thing is that it saves time and resource. Of course, the if we have some quality data, we have just removed the anomalies. Okay, so anomaly means the error. That means if we have collected data where there exists some error. Error means anything that we do not need or anything that can affect the portability or that can affect our output. That is called the anomaly or error data. Error means suppose I am expecting something but I received something. So there is a deviation, there is a gapping between my expectation and the actual actual data received. So that is called error. There is not any kind of error in the data. So whenever we prepare the data with the pre-processed data or the data with quality, it will, of course, it will save the time and it will be processed with higher quality. So that is called data preparation. Anything anyone want to ask me about the data preparation? Let's so again this data preparation preparation, the meaning of data preparation, and what is the need of data preparation. Upon these two contents, everyone is clear. Am I clear to everyone?
Yes, ma. Everything is well clear.
Okay, thank you. See, one more thing is that if there is data processing or data preparation is there, then it facilitates the feature engineering, right? What is the meaning of feature engineering? Suppose let we have a data, we have data sets, right? And we have arranged that in a model, in a relational model. So in a relational model, you know that the columns are called attributes, right? So this is one attribute, this is another attribute, this is another attributes. Okay, so these are the attributes. That means we can store your ID, we can store your name, we can store your roll number, we can store your let email address, right? So these are the attributes of the data. That means whatever the data we collected, we have to arrange the data or arrange or fill the data as in the tuples. Okay, tuples means the number of rows. So rows are generally called tuples. So it is tuple 1, this is tuple 2. And this is column 1, column 2, column 3, column 4, or you can say this is field 1, field 2, field 3, and field 4. So in case of relational data model, when we store the data in the form of row and column, the columns are called field. Okay, remember that. So how many number of fields are there? You have four number of fields. So how many number of tuples are there? You have two numbers of tuples. Okay, tuples means the row. Whenever you start filling data against the columns, so these lines are called rows or tuples. Okay. So suppose you have huge set of data and you have stored data in a relational data model. So attributes are arranged and the corresponding values are filled here. Okay, so when you have arranged the data, suppose the data is processed, right? This data is processed, every data is as per the requirement, it doesn't contain any inappropriate data in the relational data model. So it may happen that one attribute infer the another attribute. From one attribute you can find out easily the another attribute. You do not have to enter that attribute, the inferred attribute, in the original table or in the original relation, but it may happen because of some attribute you can infer or you can have or you can extract any other attribute, and it may happen that that attribute, the inferred attribute, is much more relevant to you than the existing one. Okay, so if there is the quality data, if there is the appropriate data, you can also, that also facilitate the feature engineering, or it that also facilitate the extraction of any other relevant information, any other relevant features that uh, may be more useful for your data analysis purpose. Okay, so these are the need, this is the need or by for which we are performing the data preparation method. Okay, this is the need of data preparation. Let see, this is the, if anyone asks you what is data quality. Okay, so you can see that I can say that there is quality in the data if the data is accurate, if it is adhered to the timeline, it is consistent, if it has the validity, if it is unique, and if it is complete. Okay, that means we can have that if suppose someone asks you what is the meaning of data quality, you told that these are the features that should be there in the data by which we can say data quality. Okay, besides this, how can you explain that data quality measures, what is the meaning of data quality? Data quality measures that how well, okay, uh, 1 second. Okay, everything is fine. So it measures how well a data set meets the criteria for accuracy, right? The criteria for completeness, the validity, there should be consistency, uniqueness, timeliness, and fitness for the purpose. That means you can say that if there is the data quality in the data, or there are standards in the data, it ensures that the companies are making data driven decision. That means they can make decision from the existing data to meet their business goals. If any business organization is collecting data, and if there is quality in the data, then the organization can have proper decision from the data, okay, to meet their business goals, right? So if there are data issues, like such as there are duplicacy in the data, there are missing value, there are outliers. Outliers mean the data that is not appropriate, that is the noisy one, that is called outlier. Those, if those are not properly addressed, then businesses increase their risk for a negative business outcome, okay. So the fruitfulness of a business goal or the fruitfulness of a business organization depends upon that the data that they are collecting have quality or not. So in order to achieve quality in the data, we have to prepare the data, okay. So when the data quality meets the standard for the intended use, or the data consumers, they can trust the data, okay. So if the data we are using, that is quality, it meets the standard, then the person who use the data to get the output, they are in the means the belief level increases, okay. They make sure, and they just believe that if there is quality in the data, we must have a better output, okay. So so these are what, these are the dimensions, okay. So these are the dimensions of data quality. So if a data has this much features or this much dimensions, we can say that there is quality in the data, right? So first one is called completeness. Let's discuss this completeness, okay. So completeness means this represents the amount of data that is complete and usable. That means the data that we collect is usable and it is the complete one. Complete one means the data we need actually that we have collected, right? So if there is a high percentage of missing value, it may lead to the biased one, or there is the misleading analysis if the data is not proper, okay. So we always ensure that what the data we collect, that is useful, that should be according to our need. So this is called the completeness, okay. Up to this clear, students?
Yes, ma. It's clear.
Okay. 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 So the next was the uniqueness, right? So I have just showed you the structure, that what are the dimensions in data quality. So first one was completeness, right? So second one is what? The uniqueness. So I am just sharing the, I have not shared the slide. Okay. So I'm just explaining that. So don't be panic that nothing is visible. Okay. So I have not shared anything. So let, this is the uniqueness. That means one of the dimension in the data quality is uniqueness. That means this accounts, this is what, this account that the amount of the duplicacy in the data. That means if we can say that this data is unique, that means this is, there is no duplicacy in the data, right? For example, suppose you are reviewing the customer data, you should expect that each customer has a unique customer ID, okay. So if there is duplicacy in the customer ID, whether the output will be good? No, okay. So we always ensure that the data should have uniqueness. So if there is uniqueness in the data, we can say that is the quality of the data, or we are having the quality data. So second feature was uniqueness. Third one is what? Validity, right? So validity means what? That this is one of the dimension, this is one of the feature of data quality. So this measures how much data matches the required format, or the required format or the required guidelines of the business. That means whatever we need, whether the data actually contains that. Okay, so that is called the validity, right? This is the valid data. We say that is the valid data. That means the data is more relevant to our need, to our expectation. That is called validity. Then timeliness means the data, whenever you expect data, whenever you need data for the analysis purpose, you can get the readiness in the data. We can extract the data at that time. Then we can say that there is timeliness in the data. Okay. Next was is the accuracy. So accuracy means that is the correctness in the data. So that should be corrected. That should be collect whenever we collect the data should be collected from a proper source. That may be primary source, that may be secondary source, but there should be the accuracy in the data. The data, the qualitative or the quantitative one, should be collected in a such way that there should be the accuracy in the data. Right, the data should be true one. There should be the source of truth in the data, right? So next is called consistency. So consistency means this dimension just evaluates that the data records, suppose there are data records from two different data sets. So as you mentioned that multiple sources are there for the data collection, right? So using different sources to check for the consistency data, okay, that allows that if we have the various data source of data collection and we analyze the data at each and every level, we analyze the data, it should give us the correct result. It should be consistency in all the levels of data analysis purpose. Okay, suppose we have three ways of data checking and we collected the data. So in the first methodology, we check the data, it is correct and it is given a proper suppose a particular output. In the second level, when we are checking the same data, let me say that this is the same data, same output we are getting. And in the third part, suppose the same data is checked, we can say that this is the correct or this is the exact output. Okay, so at each level the data when it is checked, it should be consistent one, right? And the last one is called fitness for purpose. That means the data should be in a such a way that it should fit the purpose or it should be according to our needs. So whatever data we need for the analysis purpose, that should fit to our requirement, to our analysis purpose, right? So these are called the quality, the dimension for the quality of the data, right? Let me present the screen again. Okay. So these are the features that or dimensions that I discussed about the quality of data. Okay. See, you can just read. This is the same explanation that I provided. That what is meaning of accuracy, what is the meaning of completeness, consistency, timeliness, uniqueness, validity, and the fitness for the purpose. Right. So these are the dimensions that our data can have for achieving the or ensuring the quality. Right. Okay. Next, see here. Very important topic. Here, we know that in case of data analysis, what we need the big data, right? Big data, that means the data that is big enough in the sense it should have huge volume, it should have a variety of data sources, it should have a velocity, that means the rate at which data can be accessed or can be processed should be faster one, and it should have veracity, that we should have quality in the data, right? So this is called big data. So when we analyze the big data, so what is the general process of our data analysis? That we collect the big data, we analyze the big data, then after analysis, we find something, right? We find the pattern or we find the trend from the analysis of the past data. Then basing upon this pattern, basing upon this trend, we take the decision which will be beneficial for the organization. Okay. Suppose as we are discussing that suppose I analyze the last 5 years data of a company, then after analysis I found that if this can be done, if a particular thing, let the particular thing will be done, then I can have this amount of cells volume. Okay, so basing upon the analysis, I found a pattern, I found a trend, then I just took the decision that I will do this month, this much amount of effort, or I will include these features, these qualities in my business, so that I can have a huge profit in comparison to the previous 5 years, right? So basing upon the data analysis, basing upon the patterns, I took the proper decision, and which will be beneficial for my organization, right? So this is the actual thing that is done. And you know about this raw data, nothing to be explained again. This raw data, this means unprocessed data, difficult to understand. And upon the unprocessed data, we apply various technology, various tools, various softwares, and we get the processed data that we call it as the useful data. Okay, see. And the meaning of raw data, the raw data that is not processed, that means it has inaccuracy, it is not complete, it has inconsistency, and is not in the proper format that where we can apply our algorithms. So these are called raw data. And in data preparation, we have to convert the raw data into a form so that we can just remove all these negative points, right? We have to remove all these negative points. For this purpose, we are processing, or we are preparing the raw data, right? So up to this, clear everyone?
Yes, Ma, it's clear.
Okay. Okay. See, uh, uh, if you remember that we have already discussed data processing, but in this class we'll just go into the depth and we'll analyze much more things, we'll explore much more things in data pre-processing. Okay, so you know that what is the meaning of data pre-processing. Today also I discussed data pre-processing means we have to prepare the data. That means we have to convert the raw data that is not in a form of being processed and not in a accurate form to to a format, so that we can apply any kind of data mining or data means data science algorithms, various data classification, various regression algorithms, so that we can have the expected output. Okay, so for the data processing pre-processing purpose, we have so many steps. What are the process, what are the parts, or what are the steps, or what are the phases through which we can convert a raw data into a processed data. Okay, so first thing is data cleaning. Okay, so data cleaning means what? The data that is irrelevant, or the data if that is not appropriate, we have to clean that data, we have to remove that data. Okay, so we have to make our data set in such a way that we can apply any method upon that, and we always need to get the expected output from the input we have. So for this purpose, we are cleaning the data. So the data we have should be relevant one. It shouldn't contain any missing part. It shouldn't contain any redundancy question. So in order to remove all these things, we have to handle that data, and that one of the process is called data cleaning, right? So data cleaning, in this process, we have to handle the missing data. We have to handle the noisy data. Okay. So missing data means, suppose as I told that this is the relational model, and the data are stored in the form of row and column. So suppose in a tuple, let I have three tuples in this. This is the column or field. These are three fields are there. Suppose student roll number is there, student name is there, and student address is there. So three columns or three attributes there, against which we have inserted the information of first student, we inserted the information of second student, we inserted the information of third student. Suppose we have stored in this way. Okay, for example, then missing data means let some few tuples have some data or have some domains. Okay, so this is called domain. This is one domain also. So domain means the value that is inputted against the particular attributes. So for one student, if I have inserted the roll number is 10 and the name is suppose X and the address is suppose Y. This is the information of first student, right? First student. So likewise, we have inserted so many students information. So let in this tuple, for example, I am saying let in this tuple there are few tuples in this model. So let in this tuple there is a domain missing. Okay, so we have not inserted or we have not received the data that is present in this domain. Okay, so let this is tuple 1 and likewise in tuple 3 there is a domain missing. So as we are getting missing data, whenever we aggregate the data to get the output, we may not at that time get the proper output. So what will we do? We just ignore the tuples. Okay, so we will just ignore the tuples. I won't consider this tuple. This is one process of data. If there is missing data, how can you just rectify or how can you get quality in the data? If you are getting any missing data, you the first step that you can ignore the tuple. Okay, this is the first method. Second method is that you can fill the missing value. Okay, so if there is missing value, you can manually enter the value in that domain, or you can just take the mean of the entire tuple, or you can get the value there. So there are so many ways that you can fill the missing value, right? So these are the two methods by which we can remove the missing value if there is missing value in the data. Second one is called noisy data. Noisy data means the data that is meaningless, right? The data that is inappropriate, that is not according to our need, that is called noisy data. So if there is noisy data in our data set, it won't give appropriate result to us. Okay. So if we deal with the noisy data, if we just consider the noisy data and perform our analysis, it will affect our result. We cannot have the appropriate result that we expect generally, right? So we have to remove the noise data. We have to clean the noisy data. So there are so many ways of how we can just remove the noisy data. So first method is called binning method. So we'll discuss the methods here. The first one is called binning method, right? So binning method means what? It is used to smooth the data. So data smoothing means data cleaning, right? So it is used for what? It is used for cleaning the noisy data. If we have noisy data in the data set, we will use the binning method to smooth the data. Okay, so how it can be done? It will first, binning method will do what? Suppose we have data set, right? So many data units are there in not in a proper order. So the binning, using this binning method, it will first sort the data. Okay, it will first sort the data either in increasing or in the decreasing order. So after sorting the data or after arranging the data in a particular way, it will it will divide the data units into bins. Okay, into bins. Bin means bucket. It's like a bucket. It's like a storage. Okay, so it is like a frame. Bin means a frame or bucket or storage. So it will divide the data sets, the data present in the data set into bins. Let, in our example, I'm considering the example, let I have divided these the data units into bins, and I have three bins, one, two, and 3. Okay, so let in one bin I have three elements. Here I have three elements, and here I have four elements. Okay, so total I have 3 plus 4 plus 3. Okay, these number of elements, those elements were there in this data set. Okay, so I just took the elements from the data set and I just divided the elements into the, or I just put the elements into the bin. So let in the first bin I took three elements, in second bin I took four elements, or in third bin I took three elements. Or you can check, or you can also give the equal number of elements in each bin. That depends upon you, right? So after putting the elements in the bin, suppose this the elements present in the second bin, there is some noisy data, right? There is some duplicacy data, or there is some data that is not appropriate. When you analyzed that, you show that in bin 2 there are some inappropriate data, there are some inconsistent data. So this is the noisy data. You won't consider this data for the analysis purpose further. So what will you do? You have to remove the bin. You have to remove the elements in the bin, because this bin contains the noisy data. So what will you put there now? So you will find the mean or average of all the data units present in other bins, and what will be the average that will be put in this bin. Okay, so this is the method that the binning applies, right? So first of all, you have to consider the number of bins there, then you have to divide the elements and put the elements into bin. Suppose the bin size is 3. Suppose we have the bin size is 3, then you have to consider 3 bins, and you have to find that how many number of elements should be there in the bin, right? Suppose bin size is 3, that means you need only 3 bins, as I told you. Let 3 bins, 1, 2 and 3. Then how many number of elements should be there in each bin? That will be total number of elements in the entire data set divided by the bin size. Let I have total number of 9 elements in the data set, and I am given that I have to consider bin 3 number of bins. I will divide 9 by 3. So it will be, the result will be 3. That means in each bin I have to put 3 elements, right? Okay. So after considering the elements, if I can see that one bin contains the duplicate values, then I have to remove the elements from that bin. So in that case, I can consider the mean of all the data sets in the bin, or the median of all the data sets in the bin, or I will take the minimum and maximum value in each bin. Okay. So let in bin 1 there are elements 14, and let it is 15, and it is 21. Okay, so I will take 14 and 21, mean and maximum, and I will find the mean or median, and I will put that value in the corrected bin, right? So this is the binning method. Next method is called regression. Okay, regression. Here you can see clustering. Okay, let's see clustering. Another method of handling the noisy data is called clustering. Binning method is one. I told you not. That second is clustering. Okay, so clustering means, you know, that we have to form the clusters where the elements in the cluster are of similar features. So here you can say the orange colored elements are stored in cluster 1, and the green colored elements are in cluster 2, and red color elements are in cluster 3. So according to the data elements present here, we divided the data elements into clusters. So now how this clustering helps in removing the noisy data? You can see how the clustering helps in removing the noisy data. Suppose this is the entire data set we have. Okay, so we just formed the clusters. It is cluster 1, 2 and 3 as per the similarity of the features. Okay, so if the elements in cluster 1 are of same feature, elements in cluster 2 are of same feature, elements in cluster 3 are of same features. Okay, so we just put the elements of similar features into their corresponding clusters. So if there are few elements left, you can see here few elements, 5 elements are left, which does not, we do not belong to any cluster. Okay, so these are called outliers, the features or the data elements that those features of the data element doesn't comply with any other data element. So we cannot put these 5 data elements left to any of the clusters. So these elements are what? These are the noisy data. Okay, so if the data elements, after making clustering, few data elements are left that doesn't form any type of similarities with any other clusters, then we have to separate these data elements. Why? Because these elements, data elements, are called noisy data, and we have to remove these noisy data. So in this way, using clustering, you can also remove the noisy data. So check once the clustering method. Okay. Clustering, yes. Clustering method is clear to everyone. How using clustering method we can remove the noisy data. The above method is called the data preparation methods. Using these methods, we can pre-process the data. Okay. So first of all, we are studying about the cleaning of data. How can you clean the data? So method was, first of all, if you have missing data, you can remove the tuples or you can fill the missing data. Okay. The second one is, if you have noisy data, there are so many methods by which you can remove the noisy data. So you can use the binning method, you can use the classification method, you can use the regression methods to remove the noisy data. So using binning method, I told you how can you remove. You can put the data elements into the bins. And how can you put the data element, that you showed, the total number of data elements and the bin size you have to divide. Okay, so the number of elements will get those number of elements to be considered in a particular bin. So if in a bin you are getting the element that are inappropriate, or that are there are redundancy in the data element, so you have to remove that. So by removing, what will you place? You will just take the mean of the data elements present in other bins or the entire data set, or you can find the median of the data elements present in the data sets or the bin, and you put that value in that particular bin. So in this way you can remove the noisy data. So if you will consider the clustering method, using clustering you can put the data elements in a cluster, right? So in cluster, in each cluster the data elements are quite similar or very similar, you can say they are very similar to each other, so that's why they are forming a cluster, right? Cluster means a group. So if there is a friends or friend circle, if there is a friends group, that means all the candidate in the friendship group, they have same mentality, so that's why they are forming a group, right? So if you have a friendship group, that means all the students in that friendship group, they have same mentality, they have same behavior, they have same means thoughts, so that's why they are sharing a particular group. Okay, so whenever you form a group, depending upon the similarity of the data elements, there may be, if there are some data elements that are not belonging to any clusters, that means they are the noisy data, they do not have particular, they do not have suitable features, so that we can cluster them. Okay, so if we find the outliers or the data element that doesn't form a group or form a cluster, that are those are the noisy data, and we can remove those noisy data. So this can be done using clustering also, that I explained. So am I clear to everyone? Okay, sure. So next start. So next method of data cleaning is called regression, right? So see, regression, that you all know, this is a predictive analysis or predictive model that predicts the relationship between dependent and independent variables. So what is dependent, what is independent variable? I told you, I explained already, right? So whenever we say about regression, we have some data elements, and we predict the data elements, or we analyze the data element to predict something, right? So we need independent variable, we need dependent variable. Okay, so how regression can remove the noisy data, right? Suppose there are, you know, that there is two types of regression that you might have studied in the AI and ML class. This is a linear regression and multiple regression, right? So in case of linear regression, we have to find the mathematical relationship between the variables, right? Y, the suppose the example is y is equal a plus bx. Here x is independent and y is dependent variable. So whenever you manipulate the value of x, the value of y also changes. Okay, so x is the independent one, y is the dependent one. That means this is the input, this is the output 1. So here in this relationship, if we'll consider this kind of relationship mathematical equation, so when we manipulate the value of x, we can correspondingly get the value of y. So we can say that if the value of x changes in such extents, the value of y can also be achieved in this way. So it shows the relationship between x and y, right? So if we'll consider the multiple regression, the analysis between the various independent and the dependent values. So let y is the output variable, and here x1, x2, x3, so on, are various types of independent variables are there. Numerous independent variables are there, and whenever we apply or we change the value of the independent variable, so according to that they affect the output variable. So that means if we just provided or we take the various inputs, that may be in a case of single independent variable, that may be in the case of multiple independent variable, we just received few outputs according to the input. Okay, so if we plot all these things, if we analyze all these things, or if we analyze all the input and the output data, and that is tested in, suppose we are testing using the MATLAB, and the value is plotted, right? Plotted, and a line is drawn as per the value, as per the result we received for the value of changing of x1, x2, x3, the value of y we received, just we plotted. Okay, this is the input, this is the output, this is the input, this is the output. So according to the data we received after analysis purpose, or after using MATLAB, we just plotted the value, right? Suppose we plotted the value. So let the few data here, the data are very close to each other, right? So data, we can draw a line in such a way that maximum data is covered. Okay, so data point, those are very close to the line, are called the actual data. So these are the data point, those are very close to the line, then these are called the actual data. And the data that are far from the line, so these are not the actual data, these are the noisy data. Okay, so in this way we can have which one is the actual data, which one is the noisy data. So after the regression process, whenever we are getting some data that is not close to each other, that is dispersed in any other area or any other region, we consider that as the noisy data, and we have to remove that, right? So these are the ways through which we can clean the data. That was one of the steps in data pre-processing, right? Second one is called data integration. So after cleaning the data, we have to integrate. So we have to store data. After collecting the data from various sources, we have to store data in the, so that it can be used in the data warehouse. So data warehouse, you know, I have already discussed, the data warehouse is a place, or you can say it is a storage area, it is a temporary storage where the data after cleaning, after processed, it is stored, and from the data warehouse we consider data for analysis purpose, right? For analysis purpose. So when we want to store data in the data warehouse, we have to integrate. So what is the meaning of integration here? The types of integration, there are two types of data integration. That is, the data integration can be tightly coupled or loosely coupled. Okay, so what is the difference between two? Tightly coupled means when, suppose we received the data units from various sources, okay, and we integrated that in a particular storage area, in a particular storage area. Suppose the user wants to make a query, suppose the user wants to get something, then the user will query upon the this temporary storage and will get the data. That is called tightly coupled. Okay, so what is the meaning of loosely coupled here? Suppose the data are collected from various sources, and without storing that in a or without storing all the data in a particular storage, we have to make an interface. We just prepared a interface, or we just created an interface. So when the user needs data from any source, then the user have to interact through the interface. And let's suppose this user wants data of this one. Okay, then the user will interact with the interface, and the data can be accessed from the this data one or data one source through the interface only. Okay, so there is no place of storage, no particular place of storage of data units extracted from various sources like the tight coupling. The user queries for the data. Suppose let this user queries for this data, and the user can interact with this data through the interface only. So there is not a single place where all the data units are stored, and the user cannot access from that single place. Right? This is called data integration. Integration. Then the third one is called data reduction. It is one of the step of data pre-processing. So how can we reduce the data? So many ways are there for data reduction. That may be dimensionality reduction. That may be numericity reduction. We can extract the subset. We can aggregate the data, means the relevant data units into a particular data cube. So those are the methods. Okay. So why data reduction is there? You can know that data reduction process means it reduces. Okay, data reduction means it reduces the size of the data. Okay, so what is the meaning of data reduction? We have to reduce the size of data, and we have to make it suitable and feasible for the analysis. So in the reduction process, integrity of data must be preserved and the data volume is reduced. Okay, so whatever, whenever you reduce the data, we reduce the data volume only, but the integrity, that the features of the relevancy of the data present in that data set is preserved. So first of all, it is dimensionality reduction. That means whenever we come across any data that is, you can say, that is weakly important, then we use the attributes required for our analysis. It reduces the data size as it eliminates the outliers or outdated or redundant features. Okay, so we have to reduce the dimension. Which dimension? That are not relevant or that are very weak. If we consider those features of the data set, we cannot get a proper data, or those features that are not required for our analysis purpose, or that is not very much relevant for getting the output. We have to reduce those dimensions, or we have to reduce those features only. So that is called dimensionality reduction. Okay, see here. See, one of the example is how we can do that using stepwise forward selection, right? So what is the meaning of this one? Suppose we have the initial attributes, or we have the data units as this much: x1, x2, x3, x4, 5 and 6. Let initially we have not received any relevant data. Suppose in step 1 we just compared the features, and we just compared what we actually need in our output. So depending upon that, we get the first data that is much more relevant. Then further analysis, we get the second data. Then again, we receive the third data. That means these three, x1, x2, x5, are, you can say, the most relevant one, or you can say we have to just remove. When we analyze the data, we can have, in this way also you can treat that x1 is not relevant, or x1 x2 are not relevant, x1 x2 x5 are not relevant. Okay, so in this way we can find the data or the attributes that are not relevant enough for our data analysis. So after getting these attributes, we can say that in the entire data set, x1 x2 x5 are not relevant. So you have to reduce those data elements. Or on the other way, if suppose you are analyzing the data and you are also analyzing the required features for your data output, so you just find out that x1 is the most relevant one, then x2 is the most relevant one, then x5 is the most relevant one. So you will just keep this x1 x2 x5 and you will reduce the others. Means you can reduce the x3, it is not relevant one. You can reduce x6, it is not a relevant one. Okay, so in this stepwise forward method, you can analyze which elements are much relevant, which elements are not relevant. So as per your requirements of the data analysis or the output process, you can get the appropriate data that are much more relevant, or the data that are not relevant enough, right? So these are the method. Okay, up to this, anything want to ask me?
Yes, ma. I
Yes.
have a doubt here, please.
Yes.
This data pre-processing,
Yes.
is it these only four items you just mentioned now? Are data
uh,
pre-processing, or do we have other data pre-processing? Because from what I read, we have almost seven or so, but here I just saw
yes.
only four.
No, see that. Not for, there are so many things. Okay. So one by one we are discussing. In the data cleaning process, there are so many things that you have to clean the data. Okay. So if you say the data cleaning is the broad thing, then in between the data cleaning, you have to first think that you have to deal with the means the missing data, you have to deal with the noisy data. That is two process. Okay, two different parts. So if you will integrate the data, then you can have tight coupling, it can have the loose coupling. These are two methods. If you will consider the data reduction one, there may be so many process, so many parts, so many phases of that. Okay, so you can have the means you can have the reduction process, you can have the normalization one, you can have the data discretization one. So many things are there, it is not limited to four one. Okay, I will discuss many more things.
Okay, ma. I understand now.
Okay. Yes. See, data reduction, you can say one more thing, that if you are saying that a dimensionality reduction, you can see that suppose this is my original data and I reduce the data to this one. Okay, reduced means data is reduced means the volume of the data is reduced, but you are preserving the relevancy in the features. The features are not reduced, but rather the volume of the data is reduced. Okay, so that is called the dimension. You are reducing the dimensions of the data set. Okay, so you are just releasing the features or the dimensions that are not much more relevant. Okay, you are just preserving the relevancy or just preserving the uniqueness or the importance of the other features that are more this more feasible for the data analysis purpose. Okay, so let this is the original data. Okay, this is the original data, this is the reduced data, right? So if after reduction, you when you will combine the all the features in the reduced data, if you will get the original data, one case. Okay, when you combine the reduced data, all the reduced data, you will get the original data, one case. Second case is that suppose this is the data original data set and you reduce the data set to this one, this is the original, this is the reduced one. And it may happen that whenever you will combine the features of the reduced data set, you won't get the features of the original data set. So there may be two cases. So the first one is called lossless reduction. Okay, this is called lossless reduction. Second one is called lossy reduction. Okay, right, this is called lossy reduction. So lossless reduction means after reducing the original data set into the reduced one, whenever you will combine the features of the reduced data set, if you will get all the features of the original data set, that kind of dimensionality reduction is called lossless reduction. And whenever you reduce the original data set to the reduced one, and whenever you will combine the features in the reduced data set, you won't get all the features of the original data set. So that is called lossy reduction. So dimensional reduction is of two types, that can be lossless reduction, that can be lossy reduction, right? Next part of data reduction is called numericity reduction. So numericity reduction means you have to reduce your data set to a particular format so that it can have the less volume of data, right? Suppose you have written something in a paragraph and you are summarizing the same thing in a graphical way, which will reduce your means the lines of data, of course the chart one or the graph one, right? So in this way, in numerical numericity reduction, we can reduce the volume of data by transferring data into another form. Suppose, for example, another example, that tabular data is transformed to a graph. That is, the numericity or the volume of the data is reduced. So what is the exact meaning of numericity reduction? You have to transform your data to a particular format so that the volume of data is reduced, right? Next is called attribute subset selection. That means, as I told, that in a relational model, if you have the attributes, and suppose we are storing data against the attributes in a relational model, let few subsets are there, those are very much relevant, and using those subsets we can also infer to on using those data we can also infer to other attributes also. So we have, if we want to reduce the volume of the relational model, or we have to reduce the volume of the data stored in the relational model, so we'll just consider the subset of those relevant attributes. Okay, so if we select the attributes, or we can select the subset of the attribute that those are much more relevant for our and data analysis purpose, so the volume of the data set is can be reduced also. So this is one of the method. Next is called data cube. See, data cube is what? It is like a cluster, like a group that will contain the reduced data set. Right. So suppose, as I told in the attribute selection, subset selection, suppose I have data sets stored in a relational model. So I have so many number of relational models are there where I have stored different data. So from each relational model, I have to select, I have to find the subset of the attribute. Suppose from this relational model, I selected two relevant subset. From another relational model is there. From there, we just I selected three subsets are there. Those are means subset of the attributes. Those are much more relevant. So from the that means from the distribution of the data sets throughout the data model, we are just selecting the attribute subset, and those we considered as the data cube. So whenever we store the data in a data cube and we aggregate those relevant information, relevant data, or the relevant subset in the data cube, we can also reduce the volume of the data. So these are the methods through which we can reduce the data, right? Okay. Next. Next is called smoothing, right? So these are the data transformation. Data transformation means we have to transform the data into a particular form so that we can mine the data, we can analyze the data to get the output. So for there are just so many methods, so many ways by which we can transform the data. So first one is called smoothing, right? Smoothing means what? Smoothing means you have to smooth the data. Smooth the data means you have to remove the inconsistent data, you have to remove the noisy data. So there are so many methods that we studied today, that there is binning method, there is regression method, there is clustering method by which we can smooth or we can clean the data. Then is called data aggregation, discretization, and normalization. This much. Okay. So you can see here aggregation. Okay, smoothing just I explained now. Aggregation. So aggregation means we are summarizing our data. So suppose we have data and summarize the data in a tabular format or in a graph or in a chart, so it will be much more easier for us. It will be properly visible. It will be properly understandable. So this is the method of generalization. So we have extracted our needed data easily. Okay, so we can extract our needed data easily. Okay, so this is the method of aggregation. So we have to summarize the data in such a way that we can apply the various algorithms that we need for our data preparation, data analysis purpose. Okay, so next data transformation is the method is called generalization. Okay, so generalization means what? So let suppose you know that male and female, okay, so both are generalized as person. Okay, male and female are generalized into person. That means the lower entities are converted into higher entities is called the method of generalization. It is also there in your relational database management system, that is RDBMS. So if you have studied that, you know that what is the method of generalization. There was generalization, specialization also. Okay, so we'll study about generalization. So in this case, the lower level entities or lower level data are converted into the higher level data. So how this happens in data transformation, how it will be helpful in data transmission, because in case of data transmission we need that we have to transform one data to another format so that we can apply the data analysis method in a better way, right? So let in our experiment we have collected few data. Let this is a tree, this is a any kind of tree, this is another kind of tree, this is another kind of tree, this is another kind of tree. Okay, so if we want to transform the data, we won't consider all these tree, we will consider all these tree as a particular tree. Okay, this is a tree, that may be blue tree, that may be green tree. For example, I am taking. Okay, so let that is a particular tree X, this is particular tree Y, this is particular tree Z, this is particular tree P. So all these trees are generalized as these are the plant. Okay, these are what? These are the plants. So we will generalize all these data into a particular higher level data. So we'll consider plants instead of this particular this certain kind of trees, right? So this method is called generalization. Okay, so next is called normalization. What is the method of data transformation using normalization, right? So normalization means what? We have a data set, right? From this example you can see, we will just study the method of data normalization. Let we have a data set, and the data set have so many attributes, and these attributes have so many values. Are you getting my point? We have a data set, right? Let we have a data set, and these data sets have so many attributes, and these so many attributes are further have so many values. That means we have our data set in a complicated form. So if we apply algorithms on this complex data structure, can you be 100% sure that we will get the relevant output from the data? It may happen we can get, or it may happen we cannot get. So but we should be sure that whenever we apply data analysis method on the data, we should be confirmed that we will get the actual output. Okay, so in this case we have to bring all these values present in the attributes to a particular format, to a limit, that is called normalization. Because what is the aim of data transformation is we have to bring all the data collected in various format to a particular form that can be used by the data analysis methods easily. So using normalization we have to bring all the data to a particular limit. Okay, that is why we use normalization. For example, you can see that we speak, or we can write, or we know many of the languages. Okay. From all the languages, whatever the language we know, whatever the programming language we know, whatever we write, but computer always understand two alphabet, that is 0 and 1. So this is called standardization. This is called normalization. We whatever the things we know, but the computer will understand all these things in the form of 0 and 1. So we have to convert, we have to normalize the things in such a way that the value or the attributes or the scale will lie in between 0 and 1. We have to normalize the things into a particular limit, that is called normalization. So in case of normalization, there are so many methods, and the most unique, that means the most important methods are min max and z score technique. So I have numeric data so that you can know what is the min max techniques, how can you normalize the data, right? So let's, this is one example. I have considered few data. Okay, so if we can apply the method in a few data set, then that method can be applied to huge data set also. So as we are taking example, we cannot consider the huge data set. So for your convenience purpose, for your understanding purpose, I have brought a table with few data sets. The same method or the same procedure with in same way can be applied to complex data structure. So let I have a data that consists of the house numbers, the square root of the house, and the number of bedrooms and the price according to the square root in lakhs. Okay, so from this above data, we can find out that if I have a house, a particular square root with a number of bedroom, then what can be the price of my house? I can predict, right? So if I have, let the square root value is this much, let the price value is this much. Suppose I need any house that is of number more number of bedrooms, so the square root will go in another direction, the price will go in another direction. So I can have the complicated data one. Okay, so I do not need the complicacy in the data set. I have to normalize the data into a particular limit in the form of 0 and 1, so that it will be easier for the algorithm to analyze the things or to predict the things. Okay, so what will I do? I will use min max technique. Okay, so what is, how can do that? Suppose let this is x dash is what, this is the new value, because using this I have to make the prediction. I means the algorithm will predict that if this is the actual data set and it can be reduced to a particular format, then whenever we consider the new data, that can fit into the which thing, or that can be mapped into which one. Okay, so the new data, the x dash will can be found from the old value. This x is the old value, minimum value in the entire data set. The data set, suppose I am considering the square root portion only, and divided by the maximum value in the data set, and so you have to subtract the minimum value, right? So let's take example of the first house about the square root. Okay, so how can we transform the complex data set into a simpler one that I have to check using min max technique? Okay, so the new value will be what will be the new value? Suppose what we want to replace, I want to replace this complex value, I want to normalize or standardize this value to a particular thing. So how can I do? The original, the old value is 1200. Okay, minus from the entire data set, what is the minimum value? 1000. So 1200 minus 1000 divided by what is the maximum value in the entire data set? 1800, and minus the minimum value is 1000. So whenever you subtract this one, it will be 200 divided by 800, that is 1 by 4, that is 0.25. Okay, so we just transform this complex value to a simpler one, that is 0.25. Okay, same data, same method you can apply to 1500. It will come 0.625. Here it will be 0, and here it will be 1. That means in case of this complex data structure, we transform the complex data structure, we normalize the complex data structure into the form that lies between 0 and 1. So this is the transformation one. Same thing you can apply to price, you can apply to bedroom also. So this is one of the method by which we normalize the complex data, or we change the complex data into the simpler one. Okay, so next example is called the Z score technique, right? So Z score technique is one of the method through which we can transform the data. We have transformed the complex data to a particular one or to a simpler one, or we have to standardize the data, right? So this is the data that the number of students are there and height of the students in inches. So what is this method says? In this method, you have to find the mean. Okay, suppose I have to normalize this data, then you have to find the mean of this data. So we have to just to make total of this and divided by number of students. So when you find the total of this one, it will be 350 divided by number of students 5, and the mean is 70, right? Mean is 70. And here the standard deviation you need. Standard deviation means how this value deviate from the original one. Okay, how the value deviate from the original one. So you just find out the mean, and the mean is required to find the standard deviation. So what is the process? The data, the original data. First one is 64 minus the mean square, plus second data minus the mean one square, then third data minus the mean one its square, and the fourth data minus the mean value square, and the last data minus the mean value square with the square root of divided by 5. That means you have to divide all these with 5, then you have to find the square root, right? So when you will get the analysis of this one, you will get 80 by 50, square root of 80 by 50, sorry, 5. And when you will just simplify that one, it will be 16 by 4. Okay, square root of 16 by 4, that will be 4. Just analyze and think and say at your home that analyze these things and it will be 4. Okay, the output will be 4. So you got the standard deviation as 4 and the mean value as 70. So if you are applying the Z square technique, the new value, that means you want to transform or you want to normalize this value. So what will be the new value here? In place of 64, what we want to place? The old value minus the mean value divided by the standard deviation. The old value is 64 minus the mean value we received 70 and divided by the standard deviation here is 4. So the new value in place of 64 will be minus 1.5. So in this way, you can transform the complex data into a simpler one. You can apply this method for other data units also. Okay. So these are the method for data transformation, right? So in case of pre-processing, you can clean the data. First of all, you have to integrate the data. You have to clean the data. Then you have to transform the data into various format. Then you can store the data in data warehouse, and upon the data warehouse, upon the storage of data in the data warehouse, you can apply different methods of data analysis and can get the actual output or the result that you need. Okay. Few things are left. We'll just continue this in the next class about data pre-processing and the life cycle also. Am I clear to everyone?
Yes, ma, very much clear.
Yes, ma'am.
Okay. Thank you. Thank you so much. What's the time there now?
23 minutes after 11.
Okay. Yeah. 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 Yes. Yes. Okay. Let's just brief something. I'll start another one. Just a brief of one. That one. Let me check. Okay. One thing you see that there is the case of, suppose you are considering continuing with the data analysis, there is the case of probability also, right? Probability. So what is the meaning of probability? Is probability means the chance, right? Let me check again. Okay. See, what is the meaning of probabilities? Probability means the chance, or you can see that if we do this, if something is given, what is the chance of getting the another one? That is called probability, right? So probability means generally you can say this is the chance of getting something. For example, if I say, let I am saying that probability of sun rising in the east, what is the chance of sun rising in the east? So you will say that it's true, sun always rises in the east, so you will say that it is 100% true that sun rises in the east, right? So the probability of that sun the sun rises in the east is 1. Okay, probability of that one is 1. That means 1 is 100%. So 1 into 100 is called 100%. So whenever you are saying, I'm saying that the sun rises in the east, that you will say yes, it is true, it is 100% genuine, it is 100% true that always the sun rises in the east. So you will check that the chance of the sun rising in the east is 1. Okay. So if I say what is the probability of the sun rising in the west, okay, then you will say that its value is 0 or 0%, because that it is not true, it is not at all possible that the sun rises in the west. The sun will always rise in the east. That means this is the universal truth. So the probability is 1. This is universal false. The probability or the chance of this one is 0, right? So whenever you get the probability value, so it will be the maximum value of it is 1, and the minimum value is 0. That means the chances of any statement can be maximum of 1, and the chances of any statement can be minimum of 0. So the chances of any statement cannot be beyond 1 or cannot be less than 1. Okay, so this is called probability, right? So probability of sun rising in the east is 1/2 whether I will win or the other one will win, or whether I will lose or other one will win. Okay. So there may be 50-50 chances that I will win or I will lose. Okay. So the probability of I will win at the chess is 50% or 1/2. So always the probability value will be in fraction, or will be in decimal, or will be in percentage, right? Suppose another example, the probability of I will win the running race with three other friends. Okay, the probability of I will win the running race, or I will win the race with other three friends. Okay, so what is the probability that I will win the race with other three friends? So total number of people in the race is four, including me. So what is the chance that I will run, I will win? So it is 1/4. So among four people, so whether I will run, I will win, or my friend, three of my friends, any of the friends in among the three will win. So what is the chance of I will win the running race with three other friends? That is 1/4, right? Then another example can be, what is the probability of I will win the lottery? Okay, I will win the lottery. So let in the lottery there are 1 lakh people who have bought the, or who have purchased the lottery. So what is the chance among the 1 lakh to win the lottery? That is 1, because if I want to win in the lottery and there are 1 lakh people who have purchased the lottery, the chance or the probability of winning myself with in comparison with the 1 lakh people, that is 1 by 1 lakh. So this is the probability, right? So you can say that probability is what? It is the favorable divided by the total. Okay, so what is the total space and what you actually need? Okay, so that is called probability. The favorable upon the total number of space. Okay, so what are the chances of success and failure? The probability is that there are two cases, success or failure. So what the chance you will be succeeded? That is 1 by 2. Or what is the chance you will be failure? That is 1 by 2, for example. Okay, so total number of favorables and divided by total number of events. So it is called space, total space, event space, and this is the event. Okay, so what is to be considered divided by among how many data sets? Okay, so this is the favorable one, this is the total one, right? See that suppose you are flipping a coin. Okay, when you flip a coin, there may be head, there may be tail, right? Two possible outcomes are there. So these two are called events. These are called events that I told. Favorable conditions are events. So here, if I say that what is the possibility of getting head here? So when you flip, either you will get head or either you will get tail. So what is the possibility that you will get head? This is 1 by 2, right? This will be 1 by 2. Suppose you flipped two coins. So if you are flipping two coins, what are the possibility of getting? So this will be head or head. You can get two head. You can get tail, two tail, or you can get head and tail, or you can get tail or head. Okay, so four possibilities are there. Okay. So if anyone says, what is the possibility of getting at least one head? Okay, or what is the probability of getting at least one head here? So total how much? Total space is 4. Okay, total outcomes you get, that is 4. So what is the possibility of getting at least one head? At least means see, minimum one, maximum can be any much, any one. So here you can get a minimum one. This is head and tail one, tail and head one, that means at least one head is there. And here at least one, it is satisfying the condition of at least one, because at least means minimum one, it has two head, so I will also consider this one. So it will be 3 by 4, 3 upon 4. So this is the probability of getting at least one head if you are tossing two coins. This is called probability, right? So another is there, that is conditional probability. See, if two events are there, A and B are related with each other. Okay, these two variables, two events are related with each other. And if B is given, what is the probability of A will occur? That is called conditional probability. There is a condition that if B is given, what is the probability of getting A? Okay, so here it is again explained that conditional probability can be written as P of A by B. That means see, what is the probability of getting A if A B has occurred, where A and B are related with each other. When you will toss two coins, what is the probability of getting at least one head? So getting head and tossing two coins are related with each other. So if B is given, what is the probability or what is the chance of getting A? So this is called conditional probability, right? So here one example you can see. Let Cheteshwar Pujara is a cricketer and he has scored 50 runs. Then what is the probability of scoring 100 runs in the innings? Okay, so this can be considered as a conditional probability. Suppose these are the matches and 50 runs he has scored in 31 matches and 100 runs he has scored in 16 matches. So if we say the probability of scoring 100 runs if he has scored 50 runs, because as a person, as a cricketer, he has scored already 50 runs. What is the chance of scoring 100 runs? You can say that he has scored 50 runs in 31 matches and that 100 runs in 16 matches. So the chances of scoring 100 runs in the particular innings, if he has scored 50 runs, you can say that is 16 by 31, 52%. So there is chance of 52% chance that he will score 100 runs if he has already scored 50 runs. So we'll just studying the analysis. There is the case of data analysis also. We are analyzing the things, and we are just we are just guessing that if it has done, then what are the chances of doing any other things that is related to that one. Okay, so this is called conditional probability. Okay. So this is all about the concept that I discussed today. So this is all about today's class. So in tomorrow I will explain many more things that is left in today's class. So thank you everyone.